All right. Good morning, everyone. Welcome to today's class. And today we will continue to talk about data visualization. And we will focus on a specific package called Seaborn today. So this one is more like a modern version of visualization package. So it is built upon Matplotlib and other packages. Okay. Let's take a look. So Matplotlib is the foundational package for visualization in Python. However, there are some complaints about this package. For example, Matplotlib's APIs, like functions, are relatively low level. So if you want to create a very complicated or sophisticated plot, you have to use a very long chunk of code to create a plot. Okay. And also, Matplotlib predated pandas. So namely, it assumes that the input data is NumPy arrays, NumPy multi-dimensional arrays instead of pandas data frame. So sometimes you probably need to pre-process the data, like convert a data frame back to an array before you create a plot using Matplotlib functions. So then that motivates the creation of the Seaborn package. And this one provides an API on top of Matplotlib that offers good options, choices for plot style, color defaults, and defines simple high-level functions for common statistical plots. So high-level functions are functions that are easy to use, and they are built upon low-level functions, such as functions in Matplotlib. So usually they are similar to functions in ggplot2 in R. You just call a function and you just need to specify the data set and modify a few arguments, and then everything will be done for you immediately. You don't have to write very long chunk of code to adjust, for example, XY limit, to add title, etc. Okay. So they are all arguments in a particular function in this case. And also it works well with pandas data frames. Let's take a look. So let's load packages. I will still load the pyplot submodule from Matplotlib, and because we will compare, sometimes we will compare the plots created using Matplotlib and those created by Seaborn. You will see they are kind of similar. Okay? And also, we usually call Seaborn SNS. So this is the alias for Seaborn, and NumPy, pandas. Okay, we load all of them. And this is the way we set the chart style for the Seaborn functions. Okay. All right. So the main idea of Seaborn is that it provides high-level commands to create a variety of plots useful for data exploration or even model fitting. So let's take a look at a few of the data sets available in Seaborn. So there are some built-in data sets in Seaborn as well. So let's first take a look at plots for numeric data for one or two numeric variables. Usually we create histograms or kernel density estimation curves and density curves. So let's take a look at histograms first. We will first still use Matplotlib to create histograms, and then we can compare the result with the plot we create using the Seaborn functions. So we first create generate some bivariate normal random variables, random numbers, using the multivariate normal function again. We specify the mean vector and the covariance matrix, and we generate 2000 pairs of x and y. Okay. And then we convert it to a data frame using this data frame function, and give column names x and y to the two variables. Okay. So x and y follow a bivariate normal distribution, right? And the data frame is still called BV norm, right? And then we can create a histogram for both of them. Last time we talked about this, you can add many layers of plots into the same panel. So similarly here, we first create a histogram for x, right? And then we create a histogram for y. We let the height of bar to represent the density. So this is a plot. So, which is pretty nice. You see, it automatically chose the number, the optimal number of bars for you, and also it used two different colors for the two columns, okay, which looks nice. And alternatively, you can write a for loop to create this plot. That is because there are only two columns in the data frame, okay? And you can just let COL, the looping variable, in x, y. So in the first iteration, COL is equal to x, and in the second iteration, col is equal to y. Okay, so you create this. And even you can also, so Seaborn's hist plot function is equivalent to pi plus hist function. Okay? So if we use the Seaborn function, we can create a histogram like this. Right? The syntax is very similar. Specify the function name. Don't forget the library SNS histplot. Specify the data vector, and the stat we use to represent the height of the bar, and then transparency. So this is a kind of the parallel way to create a histogram using the Seaborn function. Very similar, but apparently it uses more bars by default, and also the function maps frequency to height, right, by default. So this is actually the default option. It's similar to the hist function in matplotlib. Right? It uses count. So a better solution is actually the following, because you will see the legend is created automatically for us. So still call the same function, and we just let data be the data frame, and without specifying x or y, I just specifying the data frame. And because both of the two columns are numeric, the histplot function will automatically create a histogram for each column in this, and automatically it adds this legend for us, x and y. And you have the option to change the stat argument to density, okay, and also adjust the number of bins, etc. Okay. So this is the Seaborn version of histogram. And next is KDE plot. Okay. Rather than using histograms to show the distribution, you can also use kernel density estimation curve. You basically use a smooth curve to show the entire distribution, the pattern of the distribution. So in Seaborn, the function is called KDE plot. The syntax is very simple, very similar. You see, specify the data frame using the data argument, and you have the option to fill the area, fill equals true. And you see by default, the transparency parameter is very low, probably less than 50%. It's quite transparent. So this is a very good way to show grouped numeric data, right? The distribution of grouped numeric data, because you can see their overall distribution, the shape of the distribution, and also because they are very transparent, you can see all of the groups of data at the same time. So this is a kernel density estimation curve. And you also have the option to overlay the KDE curve on a histogram. In this case, we should use this function, dist plot. Distribution plot stands for distribution plot. Specify the data frame, and by default, it will create histograms by default. And if you say KDE equals true, then it will overlay a kernel density estimation curve on each histogram. And don't forget to specify the stat argument to make sure that the histogram and the density curve have the same scale so that they match with each other. Otherwise, the KDE curve will be very low, because the density has a smaller magnitude compared to frequency, the count of the bars. And you can also specify some other argument to adjust the size or the dimension of the plot. Height equals 4, so this means the height is 4 inches. And aspect, so this is kind of the ratio between height and weight. So height times aspect is the width of the plot. So 4 times 1.5 is 6. So this is a 4 by 6 plot. Now you don't have to adjust it. There are default values for these two arguments. Okay? All right. Now move on to next, joint density plot. So this one apparently is used to show the relationship between two numeric variables. It's perfectly appropriate for bivariate normal random variables because x and y are like correlated by definition. And to show this kind of contour plot, we use the KDE plot function again. Just need to specify what is x, what is y, and also the data frame. So the first two dimensions are the two numeric variables. And the third dimension, the contours, shows you the joint density of x and y, the joint density of the two variables. So points on the same contour have the same joint density values. So this is a way to show the joint distribution of two numeric variables. KDE plot. So this is that two-dimensional kernel density estimation. All right. If we want to see the joint distribution and the marginal distributions together, we can use the joint plot function in Seaborn. Notice that I want to change the style of the chart from Seaborn white grade to white. We get rid of the grade. So this width function can be, this width keyword can help us to specify the chart or plot style for a specific plot. So it will not change the global option. It will only change the option for the current plot. So the syntax is width, and then specify the style, and then colon, and then indentation, and specify the plot. Right? So this is the code for the plot. We'll create a joint plot for x and y data frame, and kind equals KDE. Yeah. So kind equals KDE, that means it will create a contour plot in the main panel for X and Y, and on the margin, it will create a KDE curve for each dimension, for each variable X and Y. So this is also a very useful plot to show the relationship between two numeric variables, and at the same time, we show the distribution of each variable, which is very, very useful. The joint plot, by default, it will create a scatter plot between X and Y in the main panel and a histogram for each variable on the margin. And so this is a default option. So notice that compared to the previous one, the only difference is we don't have kind equals KDE in this function now. And so then you have a scatter plot with histograms on the margins. So this is also very useful and very practical. We can use it to show the distribution, the joint distribution of two variables. So this is a variation, the hexagon plot. So last time we actually learned how to use the hex plot function or hex function to create a hexagon plot to show the joint distribution between two numeric variables. So this is kind of a parallel version in Seaborn. Just use the joint plot function again, and kind equals hex. Then the in the main panel you have a hexagon plot, and on the margins you still have histograms. So this is a variation of the joint plot again. All right, so we're done with numeric data, numeric variables, one numerical variable or two numeric variables, the relationship between two numeric variables. Then let's move on to the next small topic, grouped numeric data, how to visualize this type of data using Seaborn functions. We will use a new data set called tips. So this is built in the Seaborn package. So we'll first load the data set, call it tips, and show the first 5 rows. Oh, I forgot to mention all of the built-in data sets in Seaborn are data frames. So it is very convenient to use these type of toy data sets directly. So these are the first 5 rows. There are a few columns. So it is about the amount that restaurant staff receive in tips based on various indicator data. The first column is total bill, and then tip, amount of tip, and then sex of the customer who paid for the bill, and then smoker or non-smoker of the customer, and day of the week. So there are only 4 days in the data set. There are only 4 unique days of the week. You will see, and time, only 2 unique values, distinct values, which are dinner or lunch. And then size is the size of the group of customers for each bill. So a very simple data set. And in addition to these 6 columns, we will add one more variable, which is the percentage of tip. So we just need to, as we have learned before, if we want to add a new column to a data frame, we just need to specify a new column like this, right, using this syntax. So it's tip divided by total bill times 100. So this is percent of tip. Right? So this is more like a better measure of tip, the size of tip. So let's first create a, in this part, the topic is grouped numeric data, right? So let's study the distribution of tip or percentage of tip among different levels of categorical variables. So we will create facets using two variables, sex and time. So one way to do it is to use the facet grade function in Seaborn to create a grade first. So how to create a grade? You need to specify the data frame that contains the categorical variables that you will use to create the grade. So tips is the data frame. And then specify the row variable and the column variable, sex and time. And then lastly, you can optionally add margin titles. So this is a great, it will just create a panel like this with some subplots. Sex has two categories and time has two categories, lunch and dinner. Right, so this margin, so this is a 2x2 matrix, and the margin title equals true will add these titles, margin titles. And then take grade, you call the map method to map certain plots into the grade. Okay, so this is the method associated with the grade. And we choose to create a histogram for each group of data. And the main variable is tip percentage. So this is a variable that we will create a histogram in each subplot, in each facet. Okay? And this is the type of plot. And then you can add some other arguments, for example, number of bins. We want to also, so this one will make sure that the four histograms share the same X scale, the same bins and the same X scale. You see 0 to 40, 15 of them. Right? So you see 0 to 40, 0 to 40. So by doing so, you can compare the histograms in a more effective way because they have the same X scale and X limit. Okay, so this is the result. So this is one way to create facets for grouped numeric variable. Alternatively, we can do almost the same thing. Instead of using pyplot hist function, we can call the Seaborn's histplot function. Exactly, almost the same plot. Basically, as we have seen before, okay, in the first few slides, the Seaborn package is built upon matplotlib. So any plot that you create using the Seaborn package can be created using matplotlib package as well. Just you need to use more code. So that's it. And an alternative way to create facets is to use the this point function in Seaborn. We have seen this before when we create the joint plot between using two numeric variables. So now this is another way. We specify the data frame and the X variable, which is this X variable is a variable we use to create a histogram. Okay. And then kind, so this is a type of plot. You can define the grades within the plot, right, within the function. So this is more convenient. You don't have to specifically create a grade and map plots into the grade. So using this function, this plot, you can do it at once. I specify the facets, how to define the facets, row and column, and also type of plot, variable, everything in the same function, which is also very convenient. Okay, so this is the meaning of high-level function, right? All right. Now, another way to show grouped numerical data is using this kind of histograms. Instead of using panels, okay, you might want to put a different group of numerical data in the same plot. In this case, you can just call the histplot function, specify the x variable, and map the categorical variable to hue. Hue is used to define the face color of the bars, and not the edge color. So hue, not color. The color is used to define the border color, the time, and then create it. So you see, automatically it uses two colors to show the two time levels, lunch and dinner. And don't forget to specify the transparency level, make it clear, make it the color shade lighter so that you can see both groups. And again, you can add a semicolon to get rid of the unnecessary information. Another example, if you want to compare the percentage of tip between the two sex groups, you can let map sex to hue, to color. And you also have the option to stack the histograms together. So they won't overlap. Instead, they will stack with each other. So now you see this plot. So male and female. So you can directly compare the heights of them, and they stacked with each other. So this is another way to show grouped numeric data. And then let's see, another option to show grouped numeric data is to use frequency polygon. So in Seaborn, we still use the histplot function. Just add element equals poly. Then it will use frequency polygon instead of histogram to show the two groups of data. And by default, they overlap. You can also choose to stack them, I believe. If you specify this argument, multiple equals stack, then they will be stacked together. Histoplot function. And yet another option is to use side-by-side box plots. So this is also very familiar for us. A typical statistical plot to show grouped numeric data. Again, now we change the style to ticks, and then create a histogram, box plot using the box plot function in Seaborn, and specify the x and y variables. If you want to create vertical box plots, then the x variable should be the categorical variable. For example, day of week. So 4-leveled: Thursday, Friday, Saturday, and Sunday. So no data for Monday through Wednesday. We only have Thursday, Friday, Saturday, and Sunday. So 4 groups. And the numerical variable should be the y variable, which is along the y-axis. So that's why it's a vertical box plot. And you can also add another categorical variable. For example, sex. You can map sex to hue. Then within each day group, you will have a pair of box plots. Each box plot is corresponding to one sex group. And then specify the data frame. So we have this nice looking side-by-side box plots. You can compare their, for example, compare their medians. Sunday has the highest median for males, but Saturday has the highest median for females. And within each day group, in general, male has a higher percentage of tip. Okay, which is in general, yeah, true, probably. Um, all right, so this is side-by-side box plot. A variation for it is the violin plot. Now just use the violin plot function. And the arguments are exactly the same, x, y, hue, data. And the violin plot can show you more details about the density or the mass of observations. But by default, it will not show you the five-number summary. But this one actually, it did. Okay, I guess this is third quartile. I guess this is the third quartile. This is the first quartile, right? And the white dot probably is the median. Right? So it does actually this one. The violin plot in Seaborn is pretty informative actually. It shows you the five-number summary. Yeah, and also the shape. Alternatively, we can use another function to create both box plots and violin plot. The function is called cat plot. Probably stands for categorical plot or something, like cat plot. Okay. So x and y and hue data and just specify kind. Kind equals box. Then you create this box plot, side-by-side box plot. By the way, if you want to create a horizontal box plot, then you let y be day and x be total bill. And you can keep this the same. And then you will have a horizontal box plot. And similarly for violin plot, you can also use the cat plot function. Just let kind be violin. Create the side-by-side violin plot. Of course, the default dimension of the plots are different. You see the default dimension of violin plot is kind of like this, kind of like 4x6. But the cat plot, the default is kind of like a square. So you can adjust it easily, but they have default options. All right. Then let's move on to categorical data. We'll talk about one categorical variable and two categorical variable cases. First, bar plots. Of course, bar plots is the most useful plot to show distributions of categorical data. So we can use the cat plot function to create bar graphs for categorical data. So let's take a look at the distribution of sex in the tips data set. Oh, not sex, actually day first, okay? I probably changed my mind when I created my notes, but I forgot to change the text. All right, so the cat plot function can be used to create a bar graph. Just specify kind equals count. So this is basically a count plot, which is a bar graph. You can change the color of the bar using the color arguments. So this is a basic bar graph. You also can use the following code using the count plot function. And then you don't need the kind argument anymore. Those other things are the same. And so basically, the count plot is a type of plot that the cat plot function can create. It's just similar to the violin plot and box plot case. Both of them can be created using the cat plot function, right? But we have the individual functions for the specific plots as well. Right? For example, let's run this, and you see you'll get the same plot. But again, the dimension is a little bit different. Okay, it's shorter, but the essence is the same. Right? The cat plot is by default is a square shape. And then let's see how to create a pie chart. Using so actually Seaborn doesn't have a function for creating a pie chart. So instead we will use this package Plotly and this submodule express, right? Plot express function pie. For more information, you can click this link or this link for this package and this function. Okay, let's first ignore this part. Okay, so how to create a pie chart using the pie function in Plotly express. Okay, very simple. Okay, so call the function. We first import the package. So we follow the convention and call it px. And then call the function, specify the data frame and names. So this names is used to name those slices. And consequently, it is the variable we use to group the data. Right? And then within each group, it will calculate the count or percentage. Right? So for this function, it will calculate the percentage for each slice. You can optionally change the height of the plot and also change the palette of the plot, color palette. So I use the qualitative set3 palette because I think it looks very pretty using this color palette. Okay, you can try other options. But anyway, this is a way to create a pie plot. However, I think there is some issue between the connection between this package and Jupyter. So after you create this plot and you download the HTML file and reopen it, the plot might disappear. It might not show anymore. But this is an issue that hasn't been resolved completely. I tried to figure out a way to let it show always, but it's not reliable. Sometimes it works, sometimes it doesn't. As you see, this part is the part that I try to force it to appear in the HTML file, but I don't think it works. I don't think it works. You can try other ways, but just let you know that it's possible. So if you do your homework and you create a pie plot using this, and you download your and when you download, why is it? Oh, can you who annotate this plot? Not me. Can you get rid of the annotation? Anybody? Anyway, okay, thank you. So, yeah, because I'm using my iPad to annotate the slides, so I allow everybody, and I have to allow everybody because I log in with my iPad. Anyway, just don't be panicked if your homework solution doesn't show the plot. It's okay. We will grade using upon your code only, so don't worry about that. And there are other ways to create pie charts, but this way it's nice looking. All right. For two categorical variables, we can use stacked or dodged bar graphs. For example, suppose we want to examine the distribution of day in different sex groups. We can do the following: call the cat plot function, let x be sex and hue be day, and then kind be count. So count means count plot, which means bar graph. So you see, you can compare the distribution of day between the two sex groups. Apparently, very different, right? So we can conclude that these two categorical variables are not independent. right? They must be related somehow, right? Namely, sex has influence on the distribution of day. All right. This is another example. We want to study the distribution of sex between the two groups of time, lunch and dinner. So also very different. That's very different. In lunch, the two sex groups have the same height almost. Probably because usually people eat in restaurant when they are at work. So female and male have the same distribution, same height, same percentage. But in dinner time, so male has much bigger count than female. Because usually when a family goes out to eat, okay, the male will pay the bill. I guess that's why. All right, so then let's move on to two or more numeric variables. We study the relationship between two columns in a data frame. So we would use the iris data set built in Seaborn. Again, the iris data set is built in everywhere. In Scikit-Learn, it is a bunch object. Okay? It's not a data frame. But in Seaborn, it's a data frame. So see, this is the first 5 rows of the data frame. The response variable is species, and there are 4 feature variables. And then in this case, if we want to study the relationship between each pair of numerical variables, we can create a scatter plot matrix using the pair plot function in Seaborn. Pair plot. This is very convenient. We just need to specify the data frame, and this is not necessary. This is optional. Okay? And then specify the height. This is also optional. So basically, this function is very smart. It will identify all of the numeric variables in the data set and create a scatter plot for each pair of them. So that's why you have a scatter plot matrix. We have 4 feature variables. That's why this is a 4x4 matrix. And of course, there are some repetitions. So these are mirror images of these. You just reverse the x and y axes. You have the same plot. And pay attention, if we choose to map a categorical variable to color, then of course within each panel you can observe the relationship between the x and y variables within each group of the categorical variable, namely species. You see, apparently it has a big influence. For example, here in this panel, the relationship between tidal length and sepal length is very steep here, but the slope is smaller in these two groups, like versicolor and virginica. The legends is provided here. And also, this mapping, we map species to here will also change the diagonal plots. By default, there should be a histogram for each numerical variable. For example, this one should be the histogram for sepal length itself. This one should be the histogram for sepal width. However, if you map species to color, then automatically it will use KDE curves to show the distribution of each variable between different categories of species, right? Because this is the optimal option to show grouped numeric variables. So by default, the diagonal kind is auto. Auto is a histogram. if the hue primary is specified, the diagonal plot will be KDE. Otherwise, it will be histogram. For example, in the next, but you can force it to be histogram by specifying this. So see, notice that I still map species to hue. So in this case, in the diagonal part, we should see KDE plots, but you can force it to be histogram, by diag kind equals hist. Of course, you see, it's not very good to use histograms for group data because they overlap too much. So now let's see the default option. So get rid of hue equals species and get rid of diag equals anything. Okay? So it should show you the histogram for each variable. Okay? We also have the option to omit the repeated half of the panel. So these parts are actually a repetition of this part, mirror image. So we can say corner equals true, then it will show you the bottom corner only. Okay. And we can also show contour plot and KTE plots. So if you say con equals KDE, then within each panel, it will use a contour plot to show the relationship between any two variables, each pair. And in the diagonal, it will use KDE curve. So a lot of different options for in this pair plot function. And it is quite useful if your data set has a lot of numeric variables. It is a quite useful function. And next is plotting regression models. This is also a very common plot in statistics. If you want to fit a regression model, simple linear regression model for two variables, then you can first create a scatter plot and optionally add a linear regression model to it to take a look. So Seaborn has this function called LM plot, right? Stands for linear model plot. It's specifically for showing regression models. Specify the data set, the X variable and the Y variable. You'll see no other arguments. And then it will create a scatter plot for the two variables and automatically add a linear regression line using the least square method. Least square method by default, and also it will add a 95% confidence interval for the mean response. For the mean response for you, 95% confidence interval for the mean response. So this is the shady area. So it's a very convenient way to show your linear regression model. You can add more arguments to the plot. For example, you can add facets. Right? Still just use the LM function. If you specify the row variable and the column variable, then automatically it will create a matrix for you, a plot matrix for you. And you can also map color, map a variable to color. If you also care about a third categorical variable, you can do this. Right? So see a very comprehensive set of plots is created using just one line of code. Right? And how about the ordering? Right? Because in this plot, there are three categorical variables, right? Smoker, smoking status, sex, and time. Right? So a general rule is that to use hue for the most important comparison. So from previous studies, maybe you think time is the most important factor that affects tip. Then the relationship between tip and total bill. If you think this is the most important, then you map this to color. And then row is the second most important, and column is the last. Column and row. Doesn't matter actually, row or column. So this is a way to create subplots for regression lines, right? And the Seaborn also have this residual plot function for you to show the residuals. Right? So by default, you just need to specify the x variable and y variable. Then the function will fit a linear regression line and pull out those residuals, EIs, and create a function for residual versus x. Right, so this is a typical residual plot. And it also provided a reference line for y equals 0 in this reference line to help you to check the pattern. So we know that if a linear regression model is sufficient and appropriate for our data, then the residual plot should be like a horizontal band of points, very random, no pattern, and the entire band should be symmetric about 0. And you should not see any like change in variation as x increases. In our data set, actually, you can see a little bit a small sign of non-constant variance. So this constant variance, this is a basic assumption for linear regression. If you see this change in the spread of residual, this is a sign of non-constant variance. You probably need to do something to adjust this. But this is not very severe because the top part is okay, but the bottom part is a little bit suspicious. Anyway, this is residual plot for simple linear regression. You can also optionally add a Loess curve to it. So if you set Loess equals true, then it will add a local weighted regression line curve for your residual plot. So why do we need this? Usually, if we think the relationship between y and x is actually not linear, maybe you should add some other terms, polynomial terms, for example, square term or even cubic term to it. If that is true, then you will see a curvy pattern in the residual plot. So for us, it's not very obvious because the Loess curve and the horizontal curve, the band, reference line are very close, actually. There's no big difference between these two, so it should be fine. So this one, the Loess curve, just help us to see if there is any obvious nonlinear pattern in the relationship between residuals and the x variable. If there is, you should add more terms to the regression function. So this is a summary of all of the plots we talked so far for different types of data and different combination of data types. For numeric variables, we can use a histoplot function to create a histogram, grouped, not grouped, or polygon plot, KDE curve, etc. And box plot is another option. For group numeric, we can use these ways. we can map the categorical variable to color. In the his plot function, we can also create subplots or facets. We can also use this plot function to create facets directly. We can use side-by-side box plots or violin plots. We can also use the cat plot function to create side-by-side box plots or violin plots. The cat plot function is very general. It is a very general function. And for joint distribution, we can use the KTE plot function to create contour plot, and also the joint plot function can also be used to create scatter plots and contour plots with some histograms or KTE curves on the margin. For two or more numerical variables, we can use the pair plot function to create a scatter plot matrix. For regression, we can use a linear model plot or residual plot for residuals. For one categorical variable, we can use a pie chart or cat plot or count plot functions. For two or more categorical variables, we use the cat plot function. So this is a brief summary of the plots we have learned so far. So now let's quickly move on to the next session. Continue to talk about the Seaborn functions. So this is called Seaborn Gallery because we will see some Seaborn functions for more fancy and informative graphical displays. So let's take a look at scatter plots again. In the last session, we talked about creating scatter plots, but they are quite basic, right? We just showed a very plain scatter plot. At most, we map color to, we map a categorical variable to a color, right? But now let's see, we can fine tune or adjust the features of points using some other method or arguments. So in this part, we will use the diamonds data set. The diamonds data set contains some information about diamonds. So C is built in Seaborn, and it's a data frame with a few variables. Carat is the weight, and cut 5 levels. Ideal, premium, good, actually 5 level, fair, etc. And color have some levels, clarity. So these 3 are categorical variables. And then we have depth. And table, I'm not very sure about this. And price, and some measures, 3-dimensional measurements of the diamond. And then let's create a scatter plot to examine the relationship between weight and price of these diamonds. So in this plot, we use the object-oriented style. So see, we create subplots and specify the figure object and the axis object separately. And then we use the dspline function to get rid of the top and right spines or axes in the plot. You see, we apply this function on F. F is the figure, okay? And left is true, bottom is true. So we choose to show the left and bottom axes only, right? Which is the price and carat. So by default, it will show all of the axes and the borders. Right? And then we specify some clarity ranking for categorical variables with string levels, with string values. The default order is alphabetic order. Of course, for diamonds, for the clarity ranking, we should not follow the default alphabetic order. It should be, we should use this order. So this is the conventional order of the clarity levels. We specify that. We'll use it a little later. And then we'll create a scatter plot using Seaborn scatter plot function. Right? So X and Y, and then hue is clarity. And we jump to here, hue order equals clarity ranking, based on this. So basically, the lighter the color, the clearer the diamond, the higher the level of clarity. Like we to see in this legend, IF is the highest clarity level. It's the lightest, which is very intuitive to find this way. And we can adjust other things, like we can let map depth to size, right? And at the same time specify the range of sizes from you specify the mean size and the max size from 1 to 8. So actually totally there are only 6 depth levels, but we can specify more numbers than the real number of levels of the variable. Okay. I think because we chose very small size ranges, we cannot tell the difference between the the size of the points very easily. You see, they are of the same, almost the same size. Anyway, so this is a way to adjust your scatter plot using Seaborn's scatter plot function. Right? We adjust the color, the size, and next, scatter plot with marginal ticks. So we will add rock plots on the margin. So now we will use a different data set, the MPG data set built in Seaborn. We have seen this before also. So this is also a data frame with a few variables, miles per gallon. So this is used to measure the fuel efficiency of a car, and number of cylinders, displacement, horsepower, weight, acceleration, model year, origin, and name. So this is the MPG data set. Suppose we want to study the relationship between acceleration and miles per gallon. So these two variables. Then we can choose to create a grade first by using Seaborn's joint grade function. And specify the x and y variables. And space, I believe this is the space between the rock plot and the main plane, the subplot and the main plane of plot. And ratio, I think this is a ratio between, the the main plot and the small plot, the rock plot. And then on G, we first map a joint plot, right, which is a scatter plot. We map horsepower to size of the points, specify the size and color, legend, etc. And then we add margin. We add a rock plot on the margins. Okay, so this is kind of like a fancy look plot. Instead of using histograms on the margin, we use a rock plot for each variable. So if our data set is not too big, then rock plot will show you the densities still, but it will not occupy a large area. So this is kind of useful sometimes. And alternatively, we can create a joint plot that shows a scatter plot and a histogram on the margin. And when you specify kind equals red, then it will add a regression line, linear regression line, and 95% confidence interval for the mean response too. So this is another way to show relationship. And sometimes we have time series data. So Seaborn has a special function for time series data as well. So now we choose this dot rate style, and we will load this data set, fMRI, also built in Seaborn. So it has a few variables: subject, time point, event, region, and signal. Right? So let's take a look at the data set, right? The basic information. It has 64 observations and 5 columns. And in particular, there is a variable called time point. So for each individual, actually we have repeated measures for each individual along the different time points. Right? And the variable, the numeric variable, is the signal. Right? And event and region are two more categorical variables, right, that can be used to group the data. So take a look at a time series plot. So in Seaborn, we can just use the line plot function to create a time series plot. See, x is, oh, by the way, there are only 19 distinct values for time plot. Right? So there are 19 different times in data set. Y is signal, right? Y is signal. Then we can map a region to color and event to line style and create this time series plot. Okay? A time series plot is a line plot. Just the x-axis must be time, and then it's a time series plot. Okay? So, and now automatically a 95% contentable for each line is created for you. And so pretty convenient for time series data. So this small session is called a Seaborn Gallery because we will just quickly go over some fancy plots that we can use Seaborn to create. Right? And next one is relationship plots. Right? So this small session is called relation plots because we will talk about one specific function called REL plot. Right? So this is used to show relationship between two numeric variables in general. Right? So let's see, we will go back, we will use the MPG dataset again. Right? So we will show the relationship between horsepower and MPG and add some more variables to the data set. Right? We map origin to hill and map weight to size. Right? So origin is a categorical variable. Right? So it automatically uses the qualitative set palette to show the three origins, like USA, Japan, and Europe. Right? And then we map weight to size. Weight is a numerical variable, right? But it has some it only has a few levels. Right? So we specify the sizes from 40 to 400, which allows a big range for this weight variable, right? For the sizes of points. So that's why you see in this plot, you see the points, the size of points are quite different, right? They're used to represent the weight of cars. So this is another one. And what if we have continuous variables and we want to map them to colors and sizes? It's definitely okay. We have seen in the previous one, we actually mapped weights to size. Right? In this plot, so we will use a different data set called planets. Right? So planets. So it has some variables like, for example, we want to study the relationship between distance and the orbital period. Orbital period, yeah. And We actually use first. Let's take a look at the details of this plot. Okay. So we specify the color map, and also we create a graphing object using the relation plot again. Right. Data set x is distance, y is orbital period. Right. And notice that the orbital period is not on a linear scale. Right? So you have the option to change the scale using the set method. So x scale, well, actually both of them are logarithmic. X scale is natural log, y scale is not natural, it's log 10. Right? So in Python, log 10 is the default option for log. So see 10 to the 1, 10 to the 2. Right? And also on the y-axis, we start from 10 to the 0, and then 10 to the 1, 10 to the 2. We use the log scale. Okay. So this shows you the way to adjust the scales of axes. Okay. And also, we map year to hue and mass to size. Okay, the mass of the planet to size. So both of them are numeric, is totally fine. Right? But if you map a numerical variable to color, it will automatically use a sequential color palette, basically one color with different shades or color saturations, to make sense. And you can also adjust the x and y axis grade, and also which axes will be kept. For example, we kept the left and bottom still. So this plot shows you some other options. And we can also create a somehow like time series plot using the relation plot function. So see, and this function, this relation plot function, also allows facets. Very convenient. For example, in this plot, we just need to map a categorical variable align to column. So this COL stands for column and not color, right? Column. Then it will create a plot for each column, right? So 2 columns. Align has 2 levels, right? Dots and stack. So this just shows you this. And what else? Yeah, other options. Facet keywords. You can specify a dictionary for that. All right, so this is another one. And next is grouped violin plot with split violins. We have seen how to create a violin plot in the previous session. But now you also have the option to create this kind of violin plot. Again, we'll use the tips data set. X is day, Y is total bills. Suppose we want to map the smoking status to color. Okay. Then by default, it will create a single violin plot for each level of smoker, right? Non-smoking or smoking. However, if you set split equals true, then it will create this kind of split violin plot. So the left-hand side represents one level of smoking status, and the right-hand side represents another level. Okay? So it's kind of one violin plot for 2 groups at the same time. So it's good for comparison actually. Okay? And you can choose the color for. Oh, by the way, inner equals quark. So this one, this option can help us to show the quartile of each group. So you see the 3 dashed lines are for median, Q1 and Q3. So you can easily compare the 3 quartiles of the 2 groups. And you can specify the colors to yes, smoking equals yes group, we use green. Smoking equals no group, we use 0.35. So this is the gray scale, right? 35% gray, black, 35% black. So this kind of the stop rate. Anyway, this is an asymmetric split curve. And the last one is a histogram, stacked histogram. Nothing really special, just we use multiple equal stack. And the point is you have the option to specify the X tick mark labels, where you want to put the major tick marks. You can specify it by yourself. All right, that's all for today. And next time we will talk about more details for graphical displays. Basically, multiple subplots and styles, different style sheets that are available in Python.